Section 3.4, higher tier, page 31, fractions as decimals, and we're introduced to terms like terminating decimal and non-terminating decimal. Alright, so let's just begin to work with that one. Non-terminating could be recurring or may not even recur. It just depends. Let's just take it a bit at a time. So things like, I don't know, 0.52 is definitely terminating because it sort of stops at 0.52. Things like 0.3 recurring doesn't terminate at all. It's a recurring decimal. And something like 0.41786361, etc., that has no pattern whatsoever, is a non-terminating decimal. Alright, so let's call it non-terminating. I don't know if that's an official term, but it's not ever going to stop. Non-terminating. Now, whilst this is not in the unit 2, I'll give you a little hint as to what's going on here. If you try to take the square root of a number that isn't a square number, e.g. the square root of 20, you get a certain answer, and I will use my calculator just to illustrate the point. So, square root of 20, what have we got? On my calculator, I have got, get ready, 4.472135,955, and my calculator's run out of space. But let me assure you, that will keep going and will never stop, because it is the square root of a number that is not a square number, so you won't get a very definite stop. Square root of 25 is 5, end of. Everyone understands. Square root of 20, you need to get yourself one of these. And as you can see, there's no repeating pattern there, so it's not recurring, it doesn't terminate, it's non-terminating. Alright, now let's jump into some questions. Which of these fractions will convert to terminating decimals? Well, question 1a, 3/5, dead easy. That's going to be 6/10, and therefore you're looking at 0.6. That terminates. 4/15 looks a little bit scary. I think I'll do a short division sum. So 15's into 4 simply don't go. Now decimal point. 15's into 40, 2 times, remainder 10. 15's into 100 go 6 times. 6 15's are 90. Remainder 10. 15 goes into 100 times, 6 times, remainder 10. I think you get the picture. So this thing will just keep rushing off in that direction there. So really, we have 0.26 recurring, and it won't terminate because these will go on towards infinity and beyond, just like Buzz Lightyear. So that's that. Next one, 5/12. 5/12. I can't tell. Let's work it out, shall we? 12's being pushed into 5's. 12 into 5, no way. Decimal point. 12's into 50. That's going to be 4 times because 4 12's are 48. 2 left over. 12's into 20 once. 8 left over. 12's into 80. Let's go for 6. Yeah, 6 times because 6 12's are 60, 72. It's 72. I've got 8 left over, and there I go again. Got a repeating pattern. So the 6's keep on going. So answer 0.416 recurring. So 15s seem to give a recurring 6. 12 seem to give a recurring 6. I don't know, I'm just shooting in the dark here. I'm just trying it out. 4/7. I know this one's a complete pain, but I'll do it anyway. Right, does 7 go into 4? Well, it does not. 7 into 4, no. Decimal point. Drop a 0. 7's into 40, go, what, 5? Yeah, because 5 7's are 35, and I have got 5 left over. Have I got this right? Yeah, 7's into 40, go 5 times, 5 7's are 35, 5 left over. Right, 7's into 50, goes 7 times, 1 left over. That was a bit quick. I know 7 7's are 49, so I'm clever now. Right, 7's into, let's extend it a bit, 7's into 10, once, 3 left over. 7's into 30, 4 times, 4 7's are 28, 2 left over. 7's into 20 will go in twice, and 6 left over. 7's into 60, oh help please. 10's no good, 9's no good, 8's good. Right, 7 8's 56, 4 left over. And we're back to 17 to 40, which I know goes 5 times. Now look, what have I got here? Let's check out my calculator. I'm not very confident with all those silly numbers. Right, 4 divided by 7. Yes, I've got it right. Right, now look, I've gone 5 7 1 4 2 8 5. If I got a 5, the cycle repeats itself. 5 7 1 4 2 8 5. In other words, 4 over 7 is 0.5 7 1 4 2 8, and it recurs from that 5 to that 8, and it repeats itself. And really, that's the way to write it, and you don't need that last 5. Once you've seen that the 5 is going to come up again in a sequence, and it is a sequence, it's a recurring pattern rather, then 4/7 is 0.171428, recurring between the 5 and the 8, as seen there. And that's got to be worth more than grade C. Come on, AQA, you're better than that. Anyway, you can find that in the foundation book. I haven't found it anyway. Right. Not interested in that one. Convert these into decimals. Not interested in that one. Arrange these fractions in order by converting them to decimals. I don't want to do that one either. What about this? Write these decimals into fractions in their lowest terms. Oh, that's called simplifying fractions. Let's do something easy, shall we? Right, what have I got here? 0.35. I don't know why I'm doing this actually. Maybe I'm on a roll. Well, what have I got here? 35 over 100. 5 goes into 35 a little bit, 7 times. 5 goes into 100 20 times. There it is, 7/20. Lovely. 1.25. What have I got here? 1.25. Well, 1's not a decimal, 1's 1. The 0.25 is basically 25 over 100, which is 1 1/4, because 25 over 100 is a quarter. Happy. Right, here's this one. Nice and challenging. 0.225. Definitely worth the grade C. I've got 225 over 1,000. Again, 3 figures after decimal points. I can pump 25s into that. I'm not allowed to use a calculator. 25 goes into 100 4 times. 25 goes into 200 8 times. 8 plus that 1 extra there, 9. 25 is going into 100 4 times, and therefore into 1,040 times. I therefore have converted that into a fraction, 9/40. No more of that, please. Express these recurring decimals as fractions in their lowest terms. This is rated at grade B, but actually, in some of the old schemes that I've worked with, it only appears in books that call it grade A. So I'm going to go for this one. And actually, in order to get some further practice, one ought to go into some of the older books to get some really horrific questions out there, and just to practice that. But I'll do one of these, and it's so important you're going to have a whole new page. Now look, I've got to convert this. So it's 0.3 recurring. I want to convert that into a fraction. Now the fact that a decimal recurs, doesn't terminate but it recurs, means it can be converted into a fraction quite easily. And this is the technique. I'm going to let x be 0.3 recurring, and then 10x has to be, multiply it by 10, bring that over, I go 3.3 recurring. Oh look, 3.3 recurring and 0.3 recurring. If I say 10x take away 1x is 9x, then I can say 3.3 recurring minus 0.3 recurring is 3. Effectively, all these recurrings that go on forever and ever in that direction cancel each other out. So what am I left with? 9x equals 3, x equals 3 over 9. In other words, x equals 1/3. And a lot of you know that a third is 0.33333, so it works a treat. Right, let's do another one. Again, I'm going to call this grade A, not grade B. Here's another one. 0.18181818, and off it goes. In other words, the recurring decimal is 0.18, recurring from there to there in an ongoing fashion. Same technique. I'm going to allow it to be called x. Now I've got 2 figures after the decimal point. and therefore I'm going to go for 100 x's is going to be 18.18 recurring. Okay, multiplied by 10, multiplied by 100. So this 18 becomes 18. All right, and of course it continues as 18181818. Now, as you can see, and I'll highlight it in yellow, that set of 18s that go on forever match that set of 18s that go on forever. Therefore I can take away 1x from 100x to leave me with 99 x's. Okay, 100 take away 1, I've got 99 x's left. 18 and all those recurrings, take away all those recurrings is 18. Alright, so they just go bye-byes, good night and good night. So x equals 18 over 99. I'm sure I can simplify that. Yeah, 9 goes into 99 11 times, 9 goes into 18 twice, and this horrible little thing here is basically 2/11.